Example 2, we're going to look at the fourth roots of the complex number 1 plus I. Oops, let's get this working better. All right, so in this case, it's going to be a little bit different. So again, we have our formula for the roots, but we need to write down the argument and we need to write down the modulus. Let's start with the modulus. If this is our z, then the modulus of z is root 1 squared plus 1 squared, which is root 2. And the argument of our z is, well, you can compute arctangent of 1. In this case, it's going to give you the argument. It's going to be pi fourths. Or you can kind of just tell it's 45 degrees by drawing the picture. 1 plus I is here. The angle is pi fourths. Either way is fine. We're looking for the fourth roots of 1 plus I, though. And so our formula is we need to take our square root of 2 further to the 1/4 power. And then we need to do cosine of our angle plus 2 pi times 0, because we're on W naught, over 4, because n is 4 in this case. And then I sine pi fourths plus 2 pi times 0 over 4. Now, the square root of 2, this is like 2 to the 1/2. 2 to the 1/2 to the 1/4 is 2 to the 1/8, or the 8th root of 2. The 0 goes away in both of these, and we're left with cosine of pi over 4 over 4, which is pi 16ths. And similarly, it's going to be I sine of the same angle. Now, your textbook has approximated this, so I don't have to. And you get approximately 1.0696 plus 0.2127i. And if you think about that, where that is on the circle, you're going to go over 1 and then up just a little bit. Well, it's much more than 1. Go over a little bit more than 1, then up just a little bit. If you think about the angle that forms, well, it should be pi 16ths. And then if you squared, then cubed, and then 4th power, you're right where you need to be. Now, interestingly, let me just point out something before we go on to the other 3 fourth roots of 1 plus I. The modulus of W naught is the 8th root of 2. The 8th root of 2 is less than the square root of 2. And so we actually start off closer to the origin for our W naught. And as we take powers, we go further and further away from the origin. It's still not very far because it's 2 to the 1/2, but we move further out. So it's almost like we're taking, well, it is exactly like we're taking sort of a fourth root in the real number sense. We also have an angle parameter to also take the fourth root with respect to. That's W naught. Let's compute the other ones, and let's do it a little bit faster. So we have a formula. We know it's going to be the 8th root of 2, cosine of pi fourths plus, in this case, 2 pi times 1. And then similarly for sine pi fourths plus 2 pi times 1 over 4. And that's going to be the 8th root of 2 times, all right, that's going to be 9 pi fourths. I think we're going to get 9 pi 16ths here, but you should double check me. And then sine 9 pi 16ths, which again, your book has approximated, and you get, let's see here, you get about negative 0.2127 plus 1.0696 I. Okay. And again, this is on a circle of radius 8th root of 2. The modulus is still the 8th root of 2. And if we were to draw a picture and take powers like we did in the previous video, we would see it getting closer and closer to 1 plus I. Let's just quickly write down the remaining 2. For the next one, instead of having a 2 pi, we're going to have a 2 pi times 2 is a 4 pi. And so 4 pi plus pi fourths is 17 pi fourths. So if you sit here and quickly do this, you get 17 pi over 16 plus I sine 17 pi over 16. And that is approximately negative 1.0696. Oops, not minus. Not plus, it's going to be a minus 0.2127i. And then lastly, omega 3 is going to be 8th root of 2 cosine. Looks like it's going up by 2 pi each time. So I think it should be 25 pi over 16. The pattern should continue. But, again, take a moment, use the formula, write it out. Right? Oops, I believe we should get 25 pi over 16, which we can approximate as 0.2127 minus 1.0696i. And let's actually take a moment and then graph these all in one graph this time. So here is going to be a circle, and our circle is not radius 1 this time. Sorry, that's vaguely like a circle. Our circle is going to be radius 8th root of 2, whatever that number is. And if we were to plot our points on the circle, our W0 is going to be here, our W1 is going to be here, our W2 is going to be here, and our W3 is going to be here. And let's just notice something. They're all kind of equally spaced apart. And what's the angle that they make? Well, we're taking the fourth roots of 1 plus I. So it turns out this is going to chop up the full 2 pi rotation of the circle into 4 pieces, or pi halves. So if you were to use some cosine angle formula to compute the angle between these as vectors, you would find the angle is pi half. That is, they're perpendicular. And this is always the case. So let me just start this. Maybe I'll start in blue. Provided, the complex number you're taking roots of is not 0, the roots of z to the n, well, let's put it this way. The nth roots of a are found, at least geometrically, by computing one root call that W, and by placing n minus 1 other equally spaced points on the circle centered at the origin of radius modulus of W. So here's sort of our one root that we found, and then we place the other so that we have n equally spaced points. Okay? And just to be clear here, these will all make an angle of 2 pi over n with each other when you go from one point to the next point. So it's a very pleasing geometric description of what the roots are. You find one of them and you just move around that circle in steps of size 2 pi over n.